Hello everyone, welcome back to my channel. In today's session, we will be discussing the algorithm of generation of prime numbers. So this is a very simple algorithm. So we will be discussing about Sieve of Eratosthenes. So where in which we will just see the steps. We will not be seeing exactly stepwise written algorithm, but we will directly go on to take an example and we will do the steps and we will see. So before getting on to the understanding of generating prime numbers, let us see what is a prime number is. So of course, the problem statement is generate the prime numbers. For example, to give an n numbers, if at all I will say n number, it is like I want the first prime numbers up till 5, or if I'm saying 100, prime numbers up till 100. So if I say prime numbers up till 50, something like that. So what is this prime number exactly? So a number is a prime if it exactly has two positive divisors, 1 and itself. So what is this divisor? This we have already discussed in the previous algorithm. So divisor is something which simply divides that particular number. For example, if I have to say 50, the divisors of 50, I can say 1, it is 2, it is 5, it is 10, it is 25, it is 50. So all these numbers are the one which divides 50 completely without zero remainder. Hence, I will call it as a divisor. So there are certain numbers, for example, 7, 13, 3, etc., which have divisors which are either 1 or that number itself. So such kind of a numbers are called as prime numbers, and numbers apart from this are called as composite numbers. For example, 50, 100, etc. Okay, so our task here is we have to generate. For example, if I say up till 100, so 1 to 100, how many prime numbers are there in between this? I have to generate that. That is my task. All right, let us go ahead and see what is this Sieve of Eratosthenes means. So this is a very straightforward method which we will be using in order to generate the prime numbers. So Eratosthenes is a famous Greek mathematician. So he came up with this kind of a sieve. So sieve, normally when we say it's a kind of a sieve where we want to, for example, if you want to prepare a tea, then of course you will put the tea across the sieve in order to stop the tea powder not to mix with the tea, isn't it? So that is what is your sieve simply means. Sieve will usually do not mix certain stuff. So if at all you do not want the tea powder to mix with your tea. So you want only the tea. Hence, you want to remove the tea powder. Hence, you will use the sieve. So in our case, we will use this sieve in order to only take out the prime numbers. So that is what this particular method means. So I'm going to use steps where I will cross out all the numbers which do not belong to the which are not prime, and then at the end of the step I will be left with only the prime number. So that is what the idea of this sieve is. So it is a simple and it's an ancient algorithm for finding all prime numbers up to a specified integer. So how do I know up to a specified integer? For example, if at all I say that 100 numbers, then what I will do is I will try and cross out all those numbers starting from 1, 2, up till the square root of that number, the multiples of all this number. For example, multiple of 1 is 1 itself, so I'm going to leave it. Next, usually we will not start with the 1 because we just want from 2. That's the reason I have removed 1 here. So 2, what are the different multiples of 2? I'm going to cross out all the multiples of 2 because reason being, I do not want the multiples of them to be there, as it is very simple and clear that they are not prime numbers because they are divisible by 2. Similarly, 3, I will cross out all the multiples of 3, etc., etc., up till the square root. Now, why the square root? Now, square root is because we want all the numbers which are less than or equal to n. So, when we use a square root, we already know that once we reach the square root, we already know that we have reached or covered all the numbers. That is the reason we do not have to go further, because when we take the multiples until the square root, it is understood that all the numbers have been covered. All right. So I'm going to go take the same example where n is going to be 100. That is, I want to generate the prime numbers up till 100. Hence, I will start from 2, 3. Multiples of 2, 3, 4, 5, 6, 7, 8, 9. And square root of 100 is nothing but 10. Hence, I will go up till 10 and I will stop. Whatever the numbers are still remaining in this particular block, that will be the prime numbers until 100. All right. So first let us start with multiples of 2. As you can see, I have highlighted. This highlight is nothing but I'm going to cross out all this. So I'm going to say that all these are not a part of. So as you can see, this 2 is highlighted in a darker shade, which means that I am just taking the multiples of that. So this is a darker shade. So I'm not going to cross that out. Instead, I'm going to cross out only the multiples of 2. So hence, as you can see, all this light red marks means I have crossed out and these are all composite numbers. So now I am left with all the other numbers, which means there is a possibility that they can be the prime numbers. Next, I will start with the second number, which is 3. As you can see, this is the 3 with which I am starting. And now I am crossing out all. As you can see in the light green, I have crossed out all the multiples of 3. This simply means that even they cannot be a prime number. So that is the next level of sieve I have used. First sieve I have used is number 2, that is multiples of number 2. Next is 3. Similarly, I'll go ahead and I will go ahead and see for 4. Next, I will see for 5. Next, I will see for 6, 7, 8, etc. until I reach 10. So the moment I reach 10, I have reached the square root of 100. Hence, I can stop here. Now, after doing all this, whatever the numbers are remaining, for example, I have 2, I have 3, I have 5, I have 7, I have 11, okay, I have 13, I have 17. All these purple colored numbers, as you can see, they are nothing but the prime numbers. So this is the very, very simple method of generating the prime numbers. All right. So this you can try. You can just create a tabular column and start with the multiples of 2, 3, 4, 5, etc. Start crossing them out, and whatever remaining will be there, which are not crossed out, are nothing but the prime numbers. Rest are all the composite numbers. So that's all in today's session, students. I hope generating the prime numbers is clear to you. So thank you for watching. Keep learning.